All right, we're back for chapter 3. So chapter 2 was all about quadratic functions. Chapter 3 is going to be all about polynomial functions, which actually is a big bucket that includes quadratics, right? So this is an example of a polynomial function, right? It's just got terms with x's to different powers. So today we're going to focus on graphing polynomial functions, but one thing you'll have to remember is when it's asking you to put a polynomial in standard form. What does that mean? That just means to rearrange the polynomial so that the powers are in decreasing order. So if I was to put this in standard form, it would be 2x cubed minus 4x plus 9, right? The cubic would go first, followed by the power of 1, and then the constant. So just remembering that's standard form. Okay. If you're asked what is the degree of a polynomial, so in this case the degree would be 3 because it is the highest power on the x that we have. So this would actually be a cubic polynomial. Leading coefficient, right? You guys should remember this from chapter 2. The leading coefficient here would be a 2. And then remembering that these individual parts are called terms. So this polynomial has 3 terms. Just some vocabulary you have to remember. You can also know that this is a trinomial, right? Binomial is 2. All right, so now that we have this definition of what a polynomial is and what these different parts of a polynomial are, we're going to work through example 2 on page 132. So you can look there, but I'm going to kind of use my calculator to go through this because we're going to be talking about the end behavior of polynomials. So what happens on the end? So when it goes towards negative infinity, when it goes towards positive infinity, there's some trends. So the first thing we're going to look at, so I'll write example 2 here. The first thing we're going to look at is what is called an odd degree with a positive leading coefficient. Okay, so that means the degree is odd and the leading coefficient is positive. So this actually is an example of that, right? So let's do the example from the book. What do they have? I'm going to type in my calculator and we're going to look at the graph. So they have, for their example, 0.5 x to the third power minus x squared and plus 3. They also have this as another example, 2x to the fifth and then minus x squared, squared, and then minus x minus 2. So you can see both of these polynomials have an odd degree. The first one's to the third power, the second one's to the fifth power, and they both have positive leading coefficients. The first one's positive half, and the second one's positive 2. So when I graph them, what happens to their end behaviors? Let's see if I can get the glare off that. Here we go. I actually probably need to turn off my light so you can see. Hold on. Okay, so you can see that the end behavior on both, is see the red and the blue line, is that as we go towards negative infinity, right, the function is decreasing, and as we go towards positive infinity, the function is increasing. So we can write that down because that is a trend for functions in this category. So as x approaches negative infinity, the function decreases, right? And then as x approaches positive infinity, the function increases, right? So it's kind of got a positive correlation. Now I'm realizing with the lights off, it's hard to see. Okay, so now let's try the second example they have. So the second example they have is what happens when you have an even degree and it's still a positive leading coefficient. Right? So we're just changing the odd to an even. So they have some examples here, but to save some time, let's just make these even coefficients. So let's make this a squared, and then let's make this a sixth. See if that works out. Okay. Hold on. I think I typed something wrong. Oh, that's got 2 squareds. That's why it's not working. All right, so let's just type the 1. So x, what do they have here? X to the, they have 0.9 x to the 4th minus 2x cubed plus x squared. Oh, I hate when I do this. And minus 2x. Okay, so there we have 2 functions now that have an even degree, a 4 and a 6, and they still have positive leading coefficients, right? 0.9 and 2. So when we graph them, what are the patterns we notice? All right, so I'm noticing that as we go towards negative infinity, the function's increasing. And as we go towards positive infinity, the function is increasing. So on both sides, the function is increasing. So we could write here as x approaches positive or negative infinity, I'm just going to say f of x instead of the function. The function increases, right? It's the same examples, the same pictures they're showing in the book. So we're talking about end behaviors here. So if you want to put that up here, these are trends for end behaviors. All right, now what if we have an odd degree, but a negative leading coefficient? I'm just going to write LC for leading coefficient. So let's see, what can we change here? To make this an odd degree, I'm going to just delete the first term in that one and make that a negative. And then let's make this a decimal here. Okay, so here's what I have. Odd degrees. Yes, my first function is a cubic and my second function is to the 5th. And then it says a negative leading coefficient, so I have negative 2 and negative 1.5. When I graph those, what do I notice about the end behavior? So let me do that second one. So I'm noticing that as we go towards negative infinity, the end behavior is increasing, and as I go towards positive infinity, it's decreasing. So it's almost the inverse of this, right? So as x approaches negative infinity, f of x increases, and as x approaches positive infinity, f of x decreases. Okay, let's see if I can squeeze this last one here. So the last one we're going to investigate is an even degree, and it's going to have a negative leading coefficient. Okay, so let me change these to just, let's make these some even degrees here. Okay, so here all I've done is I've kept the negative leading coefficient, right? And I've just made the powers even. So this one's to the 4th, this one's to the 8th. So let's see. Where's that red one? There we go. So this is the opposite of the one of just like the even degree with a positive leading coefficient, right? And that makes sense. If you think of an x squared function, it opens up. Once you make the leading coefficient negative, it drops down. So how can we describe the end behaviors here? Well, as x approaches positive or negative infinity, doesn't matter which direction, right? The function decreases. So those are some of the trends we've noticed by looking at those graphs. Okay, let's move on. We're going to go to example 3. Example 3 says f of x equals 0.5 x to the 4th plus 3x squared plus 2. And they're asking us to sketch the graph. All right, so let's make a table of values, okay? So let's just start with, in the example, they went from -3 to +3, so let's do the same thing. Okay, and so instead of working out and plugging all of these in, I'm just going to write them here, and if you want to check them, you can. 2, 4.5, 6, and 11.5. negative 11.5. Okay, so we can notice it starts off at negative 11.5 at negative 3, and then it goes back to negative 11.5 at positive 3. Okay, so from negative 11.5 to 6, the function is increasing, right? Okay, and then from 6 to 4.5, it's decreasing. And then from 4.5, it's actually decreasing all the way to 2, right? So here, this part. And then again, from 2 to 6, it's increasing again because it's going up. And then the last part from 6 to negative 11.5, it's decreasing. So the reason we're writing this is because if it's changing from increasing to decreasing, there has to be a turnaround point, right? So that's something to think about. And what does that mean? So if the function's increasing and then all of a sudden it starts decreasing, there has to be some point, right, where it turns around so that it can go from increasing to decreasing. So we know that there's a turnaround point there. We know there's a turnaround point here, and then another one in between those two, right? So somewhere between x is 1 and x is 2, it's turning, somewhere between here, right? X is 2 and x equals to 3, it's turning around. And somewhere between x is negative 1 and x is 0, it's turning around. And then somewhere between x is negative 3 to, x is negative 2 to negative 1, it's also turning around, right? In those points where it's switching from increasing to decreasing. So some other things we know is that since this is an even function, or it has an even power and a positive leading coefficient, we know that the end behavior is it starts with going even degree, positive leading coefficient. Oh, this is what I forgot. I was like, wait, that's not true. I forgot to write the negative from the book. So now when you plug those in, it should actually work. This is negative 0.5. So this is a negative leading coefficient, and it has an even power. So I know my end coefficients, or my end behavior, if I look at that for negative leading coefficient with an even degree, is that it's going to go down on both ends, right? So kind of what we wrote here, even degree, negative leading coefficient. It's going to decrease on both sides. So let's just sketch this with what we have. I'm going to make it a different color for sketching. So I need to go from negative 3 to positive 3, and of course I didn't leave enough to go to 11.5. I'm just going to go by 2s. 2, 4, 6, 8, 10. So 12 will be up there, right? 2, 4, 6, 8, 10. This is negative 10. Okay, so let's graph that. So at negative 3, it's negative 11.5. So somewhere right here. And then again at 3, it's 11.5, so I'm just going to make those symmetrical. Negative 11.5. Okay, at negative 2, it's 6. At negative 1, it's 4.5. At 0, it's 2. At 1, it's 4.5. At 2, it's 6, right? So it's kind of like a mirror, you could see it. And so we can see at both ends it is decreasing, like we said it would. And then we can see as we go up, it's got to go here, here. Can't see this point at 0, 2, and then come back up and then go back down, right? So we can see that these turnaround points exist. That's the only way it can go from increasing to decreasing, is there's a turnaround point here, there's a turnaround point here. And this is just a broad sketch, right? And it's not very great because I did it in pen. But if we graph it on the calculator real quick, let's type it. Negative 0.5 x to the 4th, and then it's plus 3x squared plus 2. So we could see that's similar to what the calculator shows. Obviously, this is much more pretty. So the idea is, like, of course, tools exist now where you can use decimals in your calculators to graph this, but the idea is that you can start thinking about what these graphs will look like, right? I know that both ends are going to be decreasing. I know it's going to be symmetrical here because as I'm plotting these points, I can see it goes up, down, you know, follows that pattern where it could fold it in half and it would be the same image, right? And I think we have one more example of sketching the graph. So let's get the function. So actually, I'm just going to show you all of this instead of writing this. So we're going to do example 4. It's asking us to sketch a graph that has these criteria, okay? So the f of x is positive from negative infinity to 4, and then again from negative 1 to 4. It's negative on these two intervals. It's decreasing on these two intervals. And it's increasing on this interval in between, actually, which falls right there. So let's graph that, okay? So for example 4, so we're going to sketch a graph. If you need to go back and write down those criteria, you can, or you can just look in your book on page 134. So the first thing we're going to do, step 1, is to find x-intercepts. Okay, where does it cross the the x-axis? And well, it's going to cross the x-axis when the function changes from being positive to negative, or from being negative to positive, right? So where does that happen? Well, it happens when x equals negative 4, and it also happens when x equals negative 1, and it also happens when x equals 4, right? So I'm just using those first two bullets to see when it's changing from positive to negative. So you can see at negative 4 it switches, at negative 1 it goes back, and then at 4 it switches again. So those are our x-intercepts. So 2, now let's evaluate the end behavior. End behavior. So if we look at that, one of the things it said is that f of x is decreasing from negative infinity to negative 2.67. So if it's decreasing, I know that the end behavior is like this, right? The slope is decreasing on the left side. And then on the right side, after positive infinity, it also says it's decreasing, so negative slope. So I know those are what the ends look like. All right. Let's talk about turning points. Okay, so turning points are when the function changes direction. When f of x changes direction. So that means it's going positive, has a positive slope for a while, and then changes to negative. Or in this case, it's negative for a while, and something happens, and it changes to positive. So when does the function change from increasing to decreasing? Well, if we look here, we can see at negative 2.67, it changes from decreasing to increasing. And then again at 2, it changes from increasing to decreasing. So let's think about it. So when x equals negative 2.67, the function changes from decreasing to increasing. Okay, so that's a relative minimum there. And then again at x equals 2, it changes from increasing, a positive slope, to decreasing. So that is a relative max. Okay, these are all helping us sketch the graph. So now let's see, let's put it all together. So I want to include all of these points, negative 4, 1, and 4. Okay, so I'm just going to go from negative 4 to 4. And I'm going to use different colors. So I know that there are zeros at negative 4, 1, and 4. Okay. I also know that there is a turning point, right, at x equals negative 2.67 and a turning point at x equals 2. So at x equals 2, it's a max. So let's just see, what is the max here? If I plug in 2, so I don't know what the y, I'm like, plug it in. They didn't give us the equation, Miss Harrington. So I know there's a relative maximum at 2, but I don't know what the y is. So I'm just going to put it right here. We're just doing a general sketch to get the shape. And then again, there's a relative minimum of negative 2.67. So maybe here. We don't know how low it is. So our sketch would be something like that, right? Decreasing on both ends, and we've got all our points there. So this is just a sketch. Okay, so I know this has been a long video. Sketching graphs can take a lot of time, right? But the idea is to get the concept of what's going on. All right, see you guys next time.